Bismillahirrahmanirrahim. Welcome to this new series. It's about the electro-pneumatic sensor, and today is part 1. So in this series, we'll mainly learn about the proximity sensors. The sensors will detect an object. It can be metal or it can be plastic. The sensor will sense that object from a distance. The sensor won't touch the object. That's why these sensors are called proximity sensors. Before starting, let me show you two things. First one is positive switching. When the sensor doesn't sense anything, then the output signal of the sensor will be 0 volt. And if the sensor does sense something, then the output voltage of the signal will be some predefined value. Vice versa, negative switching. If it detects, then the output will be 0 volt. And if it doesn't detect, then some arbitrary voltage. Now we'll start with the inductive sensors. This is a non-contact sensor. These inductive sensors mainly sense the or detects the metal objects. So let me show you how these things work. Here we have an oscillator and a level detector, right? So voltage going to this coil is definitely an AC voltage. And we also have a coil wound here. So because of this, a magnetic field will be created. And one thing is to note that this is a AC voltage, so this magnetic field will be varying. And when a metal object like this one gets close to this magnetic field, then this object will cut the magnetic field, right? Because of that, eddy current will generate on the metal object. And this law is based on the Faraday's electromagnetic induction. So, because of this eddy current, there will be another magnetic field from this metal object. So this object's magnetic field will interfere with the coil's magnetic field. This magnetic field will oppose the region of its production. In other words, the coil's magnetic field. And this is based on the Lenz's law. And due to that, the induced magnetic field of the coil will get changed. And the sensor detects the presence of the metal based on the change. So this portion will detect the change, this level detector. After a certain amount of change, this output switch will give a signal. Then we will know a metal object is nearby. And this is the symbol of an inductive sensor. In the FluidSim software, you can identify with this icon. So this is another theory. We have shielded coil and unshielded coil. In the unshielded type, the magnetic field is dispersed. It reaches more. The operating area is more. But in the shielded type, the magnetic field is way more controlled. We can direct the magnetic field in any direction in a controlled way. So these are some advantages, limitation and application of inductive sensor. This is reliable, compact, fast switching. This point is very important and it has long lifespan. And limitation is that if there is an external magnetic field in the environment, then this sensor won't work. Same as the reed switch I discussed earlier. These are some common application of this inductive sensor, and sensing depends on some factors. We have material type and sensor size. Mild steel is more sensitive, and if the coil is large, then the sensing range will be large. And this is a picture of inductive sensor which is used in the industry. The coil is present at the top portion of the sensor, and inside the sensor there will be a circuit board which consists of the output, level trigger and the oscillator. Now let me show you the symbol and working in the FluidSim software. So this is a circuit. I used this circuit in the reed switch video. You can watch that. I will move this reed switch and I have this inductive proximity switch. I will add this switch. Now let's simulate. If a metal object gets close to this sensor, then the LED will turn on and the buzzer will start to buzz. So that's all for today. If you have any confusion, then please write in the comment. Allah Hafiz.